In this video, we will talk about what we mean by a redox reaction and give you some of the historical context behind the terms oxidation and reduction. An oxidation-reduction reaction are processes by which an electron is transferred from one atom to another or one molecule to another. Sometimes these reactions are also called redox reactions. Atoms that lose an electron, we call those oxidized, and atoms that gain an electron, we label those as being reduced. So if we have an example here of sodium metal, two sodium metal atoms reacting with one chlorine gas molecule to form sodium chloride, and for the purpose here we're including the charges on the sodium and on the chlorine. What you can see is that an electron from what used to be a neutral sodium atom passes over to one of the chlorine atoms to give the chlorine atom a negative charge, and resulting in the sodium atom having a positive charge. This would normally be just written as NaCl without the charges listed, but they're included here to indicate or to help you understand where the electrons are moving. We can take these reactions and break them apart to follow where the electrons are going. We can think of these as being two half reactions. The first half reaction is the sodium atom as a solid giving up an electron to become a sodium ion. We call this oxidation. In this reaction, the sodium atom lost an electron, and so we call it oxidation. In the second half reaction, we have chlorine molecules. Each one contains, two chlorine atoms. Each chlorine atom is going to accept two electrons to become a chloride ion. So you have a chlorine molecule, it breaks apart, as well as gains two electrons to form two chloride ions. Because the chlorine atoms within the chlorine molecule each gained an electron, we call that reduction. The terms oxidation and reduction are often confusing when students first encounter them because they don't seem to have anything to do with electrons. Though we do now use them to refer to the flow of electrons, the original origin of the terms oxidation and reduction actually predate our understanding of the electron. In a series of reactions done by Antoine Lavoisier, they were looking at how metals pick up and how metal salts give off oxygen. So you have one of the famous examples of mercury oxide. Upon heating, will thermally decompose to form mercury as a liquid, and it will liberate oxygen as a gas. He performed these experiments in Paris with a series of very large magnifying glasses that focused light down onto his reaction here, which would heat up the sample of mercury oxide and liberate oxygen. So the term oxidation was historically used for the process by which metals gained an oxygen atom. So you would have an iron atom picking up oxygen atoms to become iron 3 oxide. The process here, it gains oxygen, right? So the term oxidation means putting oxygen on to the metal. So here, the iron is oxidized. It picks up an oxygen. The historical definition for reduction had to do with how, at the time, people would measure things. So back in the late 1700s, early 1800s, and even into the early 1900s, the primary method of investigation was by weighing things. So if you took that same iron 3 oxide, rust, and heated it up, you would get iron metal back, and it would give off oxygen. If you put this on a balance, what you would find is that the reactants weigh more than the products, particularly since when they were weighing it, they weren't weighing it in closed containers. So the oxygen, when it was liberated, left the container, and so what they would observe is that it appeared that their substances reduced in mass. And so the term reduction refers to the reduction in mass Later, we started using these terms to refer to the transfer of electrons, where reduction is the gain of electron and oxidation is the loss of an electron. So if something loses an electron, it's said to be oxidized. We will later see that this holds true for, in this case, iron. Iron gives up 2 electrons to each one of the oxygen atoms and is therefore oxidized. Here, your iron oxide, when it's separating, the iron itself will pick up 2 electrons, and the oxygen here will give off 2 electrons to form iron metal and oxygen as a gas. So a quick little shorthand for when you're looking at reactions, figuring out whether a process is oxidation or reduction. Reduction is the process that occurs when the oxidation number, which we will talk about in subsequent videos, when the oxidation number of an element decreases. So the element gains an electron. Often when compounds lose oxygen, as with the iron example or the rust example in the last slide, that is a reduction process. Compounds typically that gain a hydrogen atom, those are often reduction reactions. Or if you have a half reaction, which we'll get into in several videos from now, a half reaction that has the electron as a reactant. These are all indicators that you're working with a reduction reaction. Oxidation is a process that occurs when the oxygen number of an element increases. This happens through the loss of electrons. If the compound gains oxygen molecules or oxygen atoms, this is a good indicator that it has been oxidized. But the most reliable way of determining whether oxidation or reduction has occurred is figure out what your oxidation numbers are and make your decision based on that. If a compound loses hydrogen, this is also a common indicator of an oxidation process, though there are exceptions to that. Also, if you have a half reaction that has electrons being produced, this is a good indicator of an oxidation reaction.